one is to draw, so note, second one is to draw the end elevation, of a truncated hexagonal prism. To draw the end elevation of a hexagonal, truncated hexagonal prism. So there are two methods you can use to draw your hexagon. I'm going to do the line method, so just measure the length of the line and the angle, all right? I can't remember which one that, the one I sent you, if the gentleman showed the circle method, so use a circle and so on. But I'm doing the line method. I'm going to start your hexagon, so it would look like this. This one would look like this. So again, you join on the right, and then you're going to pull our line to the left. Right, so this is the one that we're doing at the top here. So I'm going to start with that's the hexagon. The length of the side, 25 millimeters. The angles, the outside angle here will be 60 degrees. So I'll show you how we do the 30, 60 degrees. So I'm going to start with a horizontal line. That line, measure that distance as 2.5 centimeters. I don't think I would scale mine. So using your set square now, your 30, 60 degree set square. With a hexagon, the angles that you use is the 60 degree from the 30, 60 degree set square. So I'm going to place my set square in an upright position. So I start with the horizontal line, which is 2.5 centimeters or 25 millimeters. The angle here is 60 degrees, this angle. So I'm going to draw my line like this. Wiper effect, next side. Extend your line, and then you're going to measure your distance now as 2.5. 2.5, 25 millimeters. So you measure, you raise the excess. Right, so you place the set square in the upright position. This angle is 60 degrees, so draw the line up. Wiper effect, slide, draw the angle on the other side. Make sure that both lines are 2.5 centimeters. 2.5 centimeters. 2.5 centimeters. Going again. Better? Go on that. No, not yet. 2.5 centimeters, 25 millimeters. Now I'm placing my set square in the same position I had it to create this angle. What I will do now is to slide, 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 and I'm going to draw this angle here using my 30 degree, 60 degree set square, sorry. So you put it up, so it was like this to give you this angle, slide, draw your line. So you draw your line, measure your length is 2.5. So all of the sides are the same. Create a wiper effect again. Am I going too fast? Yes? Alright, so let me cross. So all you're doing is using your 30-60, put it upright, and then like this to get your angle on this side. Up to give you this angle, to give you this angle. So measure the distances now. All of the sides are the same. 2.5, 2.5, 2.5, 2.5. 2.5. So measure it 2.5. Remember, you must use your set square and the t-square together to give you this hexagon. Otherwise, if it's not done properly, then your figure will be tilted. You'll get inaccurate distances, so make sure that you do it properly. Next one. So this side here now, this side is parallel to this side. So I had my set square up to give me this one, to give me that one. I turn it like this to give me here. So all I will need to do is to turn it back this way. Draw up your line, measure your distance. Make sure that your distances are correct. And the last side you connect it. Last side you connect it, you can use your t-square. Draw your last side. So this here is the hexagon. So let's see if we can do the elevated view. And by the way, elevation means the upright view. Alright, so we're doing the upright view. So create a space between that and your elevation. Here we created a space. So that you can use any continuous distance. Here, so I'm creating my space. Creating my space. And I'm going to extend now. So I'm going to extend now my corners. I have a corner here, a corner here. This corner is going to align with this corner. This corner is going to align with this corner. And then I have this corner. So I'm going to pull up 1, 2, 3, 4. So this one requires less lines than the cylinder that we looked at. So put your set square on the t-square, do it properly. So extend. So line 1, line 2, line 3, line 4. We are now truncating at a height of 45 degrees, 25 millimeters, 45 degrees. I hope you all have space for that. So, measure your 25 millimeters, 2.5, and this time you're using your 45 degree set square. So we're cutting now at 45 and not at 30. So this angle here now is 45 degrees and not 30 degrees. So you measure it 25 millimeters for your height, you're truncating at 45 degrees. The height, 25. You're using your 45 degree set square now to truncate your figure. Lines here will be dark. As I said, you always darken at the end. These lines. You can handle this one on your own. Okay. Remember, when you're doing end elevation, you must use your 45 degree set square to extend your line. So you must do your 45 degree set square. With the cylinder, we had to pull all the lines that touch in the circumference. In this case, we have sides. So you want to pull the sides, the end of the side, or let me say the corner, or the vertex, yeah, or the vertices. So 1, 2, 3. You pull those lines across, pull them over, pull them up, sorry, pull the line over, and then I'll only show you how to plot. The only thing I'm doing is showing you how to plot. So this figure requires sides, because as you see here, the sides are straight, right? So I'm going to start from my highest point. So this is my highest point here, right? This line, I put some numbers, so at least you can follow the numbers here. So I use 0 as my middle. So 0, middle, is carried over to the highest point, which is here. I will mark that point as my highest point. This is my lowest point. You notice that my line is also on 0, right? So my lowest point would be here. So I have my highest point, and we have the lowest point, and the highest point and the lowest point must align. The highest point, if I place the object on the side and I squeeze it, you will see that it is aligning highest point in line with the lowest point. Alright, so we have the highest point, we have the lowest point. Now as you will notice, the figure from 0, it now extends up to 1. If I put this line from 0 to 1. So here should correspond with 1. So that is going to go over on line 1. So this is the 1 with 1. 1 with 1. From 1 here. Okay, so let me do, we can do the reverse. We can do the reverse, so let me show you. So let me do the reverse. Right, so this is 0, 0, so 0 to 1, 0 to 1. So here, 0, then it goes to line 1. This is line 1. If I pull this line straight across, this is also going to go up to line 1. This is also line 1, right? So this is my first point, then slants to 1. This point slants to 1. So let me show you what actually happens. So this would look like this. From my lowest point, it slants up here now to 1 on this side, and it slants to 1 on the opposite side, right? The two lines, and I turn this, if I draw my line across, they will correspond, all right? From there, my line now comes up straight here, because you're looking at the object flat, right? So that line now comes up, and this line here also comes up. If I were to turn it and I draw a horizontal line, it's going to be in line with each other, all right? So my next point would be here. Let me just draw this here super. 1, 2. Now this, if I turn this here, 1 and 2, which is 1 here, and then we also have here. Now from that point, it slants back now to the top, the highest point. So it slants now back to the highest point. It slants back to the highest point. This here slants to the highest point. So all that is left to do is to connect this point with here, and then this point with here. Now you cannot leave the object with the opening only, because remember this is also part of the whole figure. So I'm going to now extend by darkening. So I'm extending my dark line here to the base, cross, extending this dark line back to my base. The center is also part of the figure, so it now shows that there's a slant. Right? So I must darken this line. If I leave it as it was, then I'm saying that all of this here is one. If we leave it, we're just leaving the line as a light line, we're saying that everything is in one. So I'm going to darken this line as well to show that it is two slanted sides that are there. So we started from the highest point and then we moved down. So we moved down from the highest point to this slant. Then here now becomes straight. Here becomes straight. Here becomes straight because of the nature of this object. So straight, straight, slants, right back to the middle. So it slants back to 0, which is the middle. From this point, it slants back to 0, which is the middle. Darken the opening, and you also darken the elevated piece of the object. And elevation means an upright view, a vertical view. So same will apply when we do the elevations of the house, right? Elevation means that you have upright views. So when you take a break, and I have some of the notes on the board on what elevations are. You can take a picture of it, so you will understand the elevations, and then we're going to start to understand how an elevation is formed when you have a floor plan. So that's what we'll be doing. So I'm going to give you a floor plan drawing which you're going to use. I'm going to explain how you set it up and then how we extend our lines. So once you finish this, darken your lines. The red lines must be dark. All the red lines that you see on the board. Red, dark, yellow, dark, yellow, dark. Right? So all the yellow lines dark, the red lines are also dark. So if we get through with all the elevations, I was planning for us to do 8 elevations today. 8 elevations today. Let's see how well you understand the concept, and then tomorrow God will read the foundation. So I was planning to do 4 elevations today, 4 elevations tomorrow, sectional elevation, and then Monday we'd have done the foundation. But I think people tired too. Yeah, you all been having classes since school. Yeah. So take a break, 15 minutes break. And then you will come back in 50 minutes time, and then we're going to restart the elevation in the meantime.